Good morning. So I'm going to go over the Chapter 9 test review. So vocabulary terms, look in your notes and ebooks to define these terms. So just remember with the term life insurance, it has a limited time limit. So limited time. Okay. So this one, definitely look in your notes for this. Okay. Okay. So whole life combines life insurance and an investment part. So it has a cash value. So cash value on this part. Group life insurance is a benefit covered by your job. Okay. Again, it's a limited time. Universal life insurance. Um, you can the cash value part. So it's like whole life, similar to whole life, except for the cash value can be used to pay the premium. To pay that premium that they need. Okay. So one thing to know for a traditional IRA is that the taxes are deferred. So you pay the taxes later. So when you take the money out, if you take it out early before you retire, before you're eligible for retirement age, remember we calculated that before, there's a lot of penalties, so you lose a lot of money. Okay. Okay, until the money is withdrawn from the account. So taxes are deferred. You don't pay for that until you take out taxes. Okay, Roth IRA, you pay taxes on it as you're putting money into it. So what some people do, they'll have a traditional IRA, and then when they get close to retirement, they'll convert it to a Roth IRA so that you're paying taxes on it. But then when you retire, you're not having to pay as much taxes, pay those taxes. Okay, so remember this is cost of living increase. So cost of living, cost of living adjustment. And it's based on the consumer pricing index. Social Security benefits are based on your earnings. Okay. So based on how much money you earn over over your working lifetime. So okay. For Social Security credits, remember we talked about this before. So you need to earn at least 4. Okay. So 4 credits is the maximum you can earn per year. Okay. You have to earn at least 40 credits to receive Social Security. Okay, to receive Social Security benefits. You can't unless you have to have at least that 40 credits. Okay. Mortality rate is the probability. So this is what we're talking about with this last section, section 9.4. So probability someone will die before their next birthday. Okay. So before their next birthday. The table, mortality table, lists the probabilities. So for mortality table, that's what we were just working with in section 9.4. Lists the probabilities by gender, so by sex and age. Okay, that they will die, that they're dying before the next birthday. And that's also how the companies figure like how much they need to charge for their policy and all that good stuff. Okay, so this next one. So David's opened a retirement account. So the percentage rate, so 0.0, remember we go to the left, so 0.029. Okay, compounded monthly. He wants to retire in 35 years. How much will be in the account? So we're solving for balance. If he deposits $325 a month, okay? So we are going to be using our balance formula on this. So we have to figure out how much we're going to put in there. So balance formula, so that one's going to be this one. So we're going to put in the principal, so 325. Everybody, I definitely encourage you to do this with decimals. So 1.029, okay, over 12. Okay, and then it's going to be raised to 12 times 35. Okay, remember to scroll down, and then you do -1, double parentheses. So everybody remember we have to have those pairs of parentheses, and then the rate divided by 12. Okay, so then you scroll down, and you do rate divided by 12. Okay, again, everybody make sure that you're getting those pairs of parentheses. So pairs of parentheses there. Okay, you got this. And so we put that all into decimals. And everybody double check your balance. So make sure you put this use decimals. So you get 236,149,093 cents. So that's how much David would have in his account for retirement. All right. Okay, Zach and Laura are saving for their retirement as well. But this case, they want to have $450,000 for retirement. Exciting. So they want to have $450,000. Okay. The rate, so 0.035. And they're going to deposit compounded monthly. How much do they deposit each month? Time is 35 years. Okay. So we're using all these. So we're going to use that formula. So it's going to be the balance. So the 450,000 times the rate. So 0.035 divided by 12. If you're using decimals, we do have to do parentheses around that. And then another set of parentheses. And then scroll down. And then we have to do 1 plus the rate. So 0.035 divided by 12. Raised to 12 times 35 years. Scroll left, do -1, parentheses. Okay, so we put that all in, and how much Zach and Laura need to deposit every month is $574.31. Okay, so this one is for Jose. So Jose has a taxable amount of $58,000. Pays about 20% in taxes. He's going to put $5,000 into traditional IRA. Remember, that means it's tax deferred. How much is his tax liability reduced? Okay, so we're going to take the original amount times 20% minus the original amount minus the $5,000 that he's putting in times 20%. Okay, and so that's going to give us, so he would save $1,000 in taxes. Okay, so let's look at number 5. So this is for Miss Evans. So we have, so she's 65 years old and wants to retire. So she earned $4,500 per month after adjusting for inflation. So 90% of the first 856, so 90% is a decimal, times 856, so we get 770 and 40 cents. So notice that amount is constant. We always get that one. Okay, so it's going to be the same. And then 30% of the earnings over 856. So 32% is the decimal times 4,500 minus the 856. Remember, because this is the balance. Okay, so we multiply those together and we get 1,166 and 8 cents. Okay, and then we're going to go ahead and how much will her benefit be? So we're going to add both of those together. So everybody, we add A plus B to get a full retirement account. So I'm just adding those together. Okay, so her full amount is going to be $1,936.48. Okay, she's retiring. What if she retires early? So if she retires when she's 62, that would be 30% reduction. So now we're going to take that amount. Okay, so it's going to be reduced. So it's going to be 1 minus 30%, which is so 70% basically is what she's receiving. So she's going to receive $1,355.54. So she's receiving 70% of the total. This is percent decrease. Okay, so Miguel's retirement, he wants to retire, is 770. He is retiring at 65, so it's going to be reduced by 13.3%. What will his benefit be? So again, so the 1,170, I'm going to take 1 minus 0.0133. So 1, everybody, is a 100% decrease again, everybody. So his is going to be reduced to $1,534.59. And people retire early for different reasons. They need to take care of family or their own health, so other health reasons. Okay, so now we're looking for Jesus. So we have 1,440. He's going to retire at 64, so it's going to be reduced by 20%. So 1 minus 20% is a decimal. Okay, so we're figuring out how much. Remember, 1 is the 100%. So percent decrease. So we want to know how much it's going to go down to. So it's going to be $1,152. So that's how much it's going to receive for Social Security. And again, when you retire early, people think about it a lot because then that's the amount you receive for the rest of your life. Okay, so next one, number 8. Okay, so Sophia has a pension plan. So we're coming on to pension again. So 2.1% is the percent multiplier, the highest of her 3-year salary. She's been working for the company for 15 years, and the last 3 years' salary, so these are her last 3 years. What is her monthly pension before inflation? Okay, so we're going to have to add all these together. Okay, and then we're going to have to multiply that by 15 years times 0.021 divided by 12. So her monthly pension amount, so I'm dividing by 12 because it's monthly, not annual. So go ahead and add all those together. so I got $1,888.25. Okay. They're offering a cost of living increase. So remember, cost of living, we're just going to add the 100%. So this is an increase, so it's going to be 101.9%. So it's going up. So we're going to do the full amount, pension amount, times 1.019. So we're multiplying by 101 and 9/10% as a decimal. Okay, so now she would get $1,924.13. Okay, Miguel's employer has a pension plan, so we're doing the same thing again. So this one case we're running annual, so we're not going to divide by 12. So we're going to take all those and add them together and divide by 3. Remember, they can use 3 to 5 years of your last salaries to figure out the average. It totally depends on the company. Times 15 times 0.015 is a decimal. Okay, so I'm using the percent multiplier. So we go ahead and take all those. Okay, so I got $17,985. So that would be Miguel's annual pension. Okay, Adriana has a pension plan. So this is her percent multiplier for the last 6 years. She's worked there for 15 years. This is her average salary. So they give us the average, everybody. What's her monthly pension? Okay, so it's going to be her salary times the number of years, so 15 years, times the percent multiplier. In this case, we are going to divide by 12 because it's monthly, not annual. So remember, 12 months in a year, that's where we're getting that from. So it's going to be $1,671.94. Okay, so MetLife sells a 5-year insurance policy with a face value of $120,000 to a 62-year-old man for a monthly premium of $95. Use the mortality rate table below. Determine the probability that customer lives until he's at least 65. Okay, so to at least 65. So we look at the one before. Okay, so we're going to change that one to a decimal, to a percent. So multiply that by 100. Remember, everybody, with this, be really careful that you do use all the numbers. Okay, so I get that, and then I'm going to take and subtract that amount from 100%, because this is the mortality rate, probability that he'll die. Okay, so we want to know what it is what's the rate for living. So I got 98,3433. Okay, so remember I told you we use all those numbers. That's the probability to live. Okay, so this one, you got this one, everybody. So all we do is take the rate for a certain female category. So we're going to multiply it by 100 because it says it means there is a percent chance a 62-year-old woman dying before her next birthday. So we multiply it. Okay. So we get 8.959%. That's it for this one, everybody. Got this. Okay, so for this one, so 13, it's going to be, so we're going to multiply, so 8,000 times the percent mortality rate as a decimal, so 8,000 times 0.0043, okay, and we get 34. Okay, so 34 men are expected to die before their next birthday. Okay. So before their 50th birthday. Okay, this is the probability a man will die before his 90th birthday. So if they insure 10,000 men, so we're going to do 10,000 times the rate as a decimal, so 0.0038. And then we'll go to left. Okay, and we get 38. So 38 are 47-year-old men are expected to die before their 49th birthday. Okay. Here's about a life insurance policy, 25 years, with a face value of $200,000. Her monthly premium is $54. She dies after 10 years. It's within the time of the insurance policy. So her beneficiaries will receive, they're going to receive the full amount, so the $200,000. Okay, so the full amount. Okay, because it's within the term. Okay, because it's within the term time of the policy. Okay, Mary's Hall bought a 20-year policy, pays value $150,000. She's paying $40.50. She dies after 9 months. How much has she paid? Okay, so 9 months. So we're going to do $40.50. Okay, so we're going to multiply those two together to get $364.50. Okay, how much will her beneficiaries receive? It's within the time of the policy, so they're going to receive the full $150,000. How much did they lose? So the $150,000 minus the amount she paid, so the $364.50. So $149,635.50. Okay. Okay. Angel is 35 years old. We bought a 20-year policy. So again, remember, you want to do this for your loved ones. The face value of $250,000. Her monthly premium is $67.50. She dies after the age of 60. Okay. How much has he paid? I should say he paid. He paid towards the policy. Okay. Notice I need to correct that. How much has he paid towards the policy? So we're going to do the full amount. Okay, it's a 20-year policy, so 20 years, 12 months. So he paid $16,200. Okay, so it's a 20-year policy. 35 plus 20 is 55 years old. She dies when she's 60. So her beneficiaries are going to receive $0. Okay, because it's after the time of the policy. Okay, everybody, you got this.